Hello, everybody. My name's Jordan Punch, and I'm a senior systems safety engineer with a background in electrical engineering. I primarily work in JTC1 SC42 Joint Working Group 4. The Joint Working Group 4 is focused on AI safety and is developing the TS22440 series for functional safety and AI systems alongside TS25223 for uncertainty quantification in AI systems. I'll mention that Eric Reynolds is the founder, chairman, and head of innovation at Reynolds and Moore, and helped organize everything so that I can speak to you here today. So today I'm representing Reynolds and Moore alongside RMAI. Reynolds and Moore is an engineering safety company primarily focused on innovation. Specifically, we tend to work with our other companies who are passionate about safety but have complicated engineering problems that can't be entirely addressed by traditional safety. RMAI is a certification company that focuses on AI driven products. We are officially partnered with NVIDIA to support their Halos AI Systems Inspection Lab ecosystem. And finally, we have a podcast called Safety Third that you can tune into. Please feel free to reach out with the contact information listed above. So we'll start out with an example of one of our customers' concerns. Although I'll describe this particular chain of events as a sequence, the individual parts of this chain can be potentially removed or rearranged, and most of the content will remain valid. So we'll start at the leftmost side of the sequence: malicious actors, either external or internal. Inject bad training data into the AI system, AI data training set. They act either with knowledge of the intended AI model reward function or under an assumption of the AI model reward function. Their intent is to maliciously manipulate an AI system that uses their bad training data. The next piece in the sequence is that company A aggregates training data. The training data could be for hand signal recognition, traffic sign recognition, or something more complex like maintaining stability of a bipedal object. Many of these types of data sets can be purchased on the market now. Let's say that company A has the best intent and monitors for malicious training data, but something either slips through or maybe one of their employees happens to be the malicious actor. Either way, company A unknowingly packages up the training data and sells it to company B. Company B actually makes the AI model using that bad training data. If company B makes a product that includes the AI model, the AI model trained off of this bad data is now released into the world whenever they sell it to their customer or use it internally. With the AI released into the world, the malicious actor waits until they think it's the best opportunity to strike. Once the timing's right, the malicious actor sends some form of command to the AI. Likely, this signal will not be easily identified by a human. Think of something like a QR code where humans can't decode it. Then, the AI has been released to the public, sees this signal, prioritizes it because it's associated with the reward function, and initiates an unwanted or dangerous command. So as you can see in the chart above, moving left to the rightmost. Okay. This leads us to Annex C of ISO 42005. Annex C focuses on how to document benefits and concerns in accordance with Clause 6.8 of the same standard. The focus of this annex is around Table C1. The table on the side is a snapshot of the security and privacy section. We'll cover what the entire table contains in a later slide, but for now, this is what the table mentions for security and privacy. In our example in the previous slide, I didn't mention that companies B AI used personally identifiable information. So, keeping with that trend, we'll say the first objective in this list doesn't apply to our scenario. This is the point of Annex C. It is intended to be a guide on how to highlight harms and benefits associated with objectives. It is not intended to be comprised of binding requirements. The second objective sounds very much like something we would be concerned about, though. The training data set is a potential vulnerability that bad actors could take advantage of and compromise our security. In the next slide, we'll see a more tailored set of objectives around our scenario. Okay. This slide shows a modified version of Table C1 in Annex C. Our example identified a cybersecurity concern, but if you look at the top of the modified table, we actually start with accountability. Accountability is listed in clause 6.8 as well as in table C1. But if you look under table C1, you won't find these example objectives. These objectives have been modified to fit our cybersecurity example. This modified table shows that the cybersecurity concern will touch on much more than just the security and privacy section identified in clause 6.8. In this example, we've identified that there needs to be some form of accountability when using training data sets, and that we need to perform some kind of periodic audit to make sure that our AI system is working well within our defined bounds as intended. Out of the two objectives listed in Table C1, I liked one and I didn't like the other. So I kept the security and privacy objective that I liked and removed the one that was not applicable for my system. As previously mentioned, this slide is a comparison between Table C1 headings and Clause 6.8.2 text headings. If you take a second to compare the two tables, you'll see that both tables contain accountability, transparency, fairness, reliability, explainability, and privacy. The only topic present in Table C1 and not technically present in Clause 6.8.2 is security. The point of comparing these two parts of ISO 42005 is to call out that they are linked to one another. When looking at Table C1, you should remember that it is to be taken as an example. You should reference Clause 6.8.2 with your specific application in mind and let it guide your benefits and harms table. If you find that you need additional columns for relevant information, feel free to modify the example provided in Table C1. It's also fine to implement your own version of the benefits and harms table. Again, Table C1 is provided just to conceptually assist with your own personal benefits and harms analysis. Now we'll get into Annex D. Annex D is technically comprised of four sections, but sections 2 through 4 have a bit more volume than the section 1. I've listed the titles of each of the clauses along with a 10,000-foot overview of what is contained in each of these clauses. So we'll skip over Annex D1, which is just an intro, and we'll start with Annex D2. Annex D2 recommends the use of a coordination guide for different kinds of impact assessments. AI can overlap with many other types of assessments, and because of this, there's a significant risk of duplication of work. In addition to this duplication, there may be elements that are caught in one type of assessment but not the other. A coordination guide is intended to catch these overlaps, engage interested parties with differing backgrounds, and identify dependencies between the different assessments. You'll see in the figure that there are many overlapping impact assessments. For simplicity's sake, there's no overlap between impact assessments from different disciplines. In real life, these impact assessments will have multiple overlapping areas besides what's shown here. Simply put, this annex is primarily focused on the key considerations for how to implement a coordination guide. And as you can see in the image, the lower text box, the naming conventions aren't always so nice with these. So it is really recommended that you have people from the different disciplines inform what is technically considered an assessment or not. Okay, this is Annex D3. Do you remember all of those overlapping impact assessments? Annex D3 wants you to gather all of those impact assessments that could have overlapping areas and start listing them out sequentially along an x axis. Along the y axis will be a list of ISO 42005 subclauses and numbered paragraphs. Annex D3 then wants you to fill out whether each of the subclauses applies or does not apply to that specific impact assessment. With this annex, the intent is for you to literally assign the relevant impact assessments against ISO 42005. And this is a direct excerpt from Table D1 from Annex D3. As you can see, columns 2 and 3 are dedicated to clause listing and numbered paragraph listing. Columns 4 and beyond use acronyms, but they are the individual impact assessment. These were identified as financial impact assessment or security impact assessment on the previous slides. Rows 1 through 21 are where the meat of the work will be done. Specifically, this is where you'll say whether the specific subclause or numbered paragraph applies to the specific impact assessment. Annex D4 contains text that generally revolves around figure D1. Since the text revolves around the figure, I'll focus on discussing the elements of the figure. On the right side of figure D1, you'll see a reference to figure B1. Figure B1 is found in Annex B. If the reference to figure B1 is followed, you will find that the 6 blocks highlighted in red and gray in figure D1 are also highlighted in gray in figure B1. Effectively, a part of figure B1 is sliced out and placed as the highlighted section in figure D1. The 6 blocks highlighted in red and gray in figure D1 represent the impact to individuals and society after 3 potential system level effects. Figure B1 must be referenced to understand that each row comprising of 2 unique boxes are associated with 1 potential system level event. So, the 2 boxes highlighted in green are in response to system event number 2. The above 2 boxes would be in response to system event number 1, and the below 2 boxes would be in response to system event number 3. In the same gray and red highlighted area, you'll see references to ISO IEC 23894 in all 6 blocks. ISO IEC 23894 provides guidance on risk management for organizations developing, providing, or using AI systems. The 10,000-foot view is that AI risk management discussed in ISO IEC 23894 focuses on the organizational level and is useful to ISO 42005, but casts too wide of a net. For the purposes of Annex D, we only want a product or service level oriented view instead of an organization level view. When pared down to the product or service level oriented view, the AI system impact assessment can be compared amongst other types of impact assessment documents. The system or operational level of figure D1 simply shows that potential events will be associated with multidisciplinary impacts that have some likelihood of occurring. The relationship between these boxes will then be considered the results of the risk assessment. The dark gray rectangles on the top portion of figure D1 shows that this process happens below the organizational level. And finally, this is the reference figure B1. In the highlighted red area, you can see the 6 cutout blocks, which are referenced by figure D1. Annex B is out of scope for this video, so please reference the Annex B video for more context around figure B1. And that's all I have today. Thanks, everybody.